All right, so if we're going to plug this value in, pull up the calculator here. You can use mine as if unless you have your own. So we're simply going to plug that in exactly like we see it. 294,105 open parentheses 1 plus 0.0, excuse me, just 0. Um, 0.085. Okay, my point is not working here. Move this out the way. So 0.085, close parentheses, all raised. So hit the raised key right here, all raised to the 37th power. Hit enter. There we go. After 37 years, we now have looks like 6,017,000. So 6,017,000 314 point. Now here's a good discussion point. 314.67. So we obviously cannot have 0.67 of a student. This is a female athlete participating in sports. So you really, if you don't have a full student, you should probably round down in this case. Since we can't have a full student, this would be female or female athletes. Female athletes. There you go. So this is what today is all about: is applying the exponential growth in this way. So let's do a couple more practice problems. So right now, I want you to see how far you can go on your own, but I'm going to do one more example with you before you try example 3 on your own. So example 2, looking at the population of Johnson City in 1995 was 25,000. Right away, I'm going to label that. I know right away, since this is my starting time, this better be my starting amount. That's my A value. Next, it says that it's growing. That's growing at an average rate. So we know this is growth because it's growing. And it's growing at an average rate of 3.2%. So right away, I know two things. I know my A and I know my R. So my A value is at 25,000. So Y equals 25,000, open parentheses. The always going to have the 1 plus. It's 1 plus because it's growing. My R value, my R value is 0.032. So you convert your R, your percentage to a decimal, and it's all raised to the t power. So there's your function. There's your actual equation. How would we figure out what the population of Johnson City is in the year 2020? Now, I want you to be careful. Do not, for the life of you, do not take 2020 and plug it in. Very, 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 very wrong. You don't want to just plug in that 2020 because you're saying that it's been 2020 years since the population started. It hasn't been. Think about when we started. It said that we started, this function started back in 1995. This was my start in 1995. So if we want to figure out what our time has been, if we want to figure out that t value, we have to take the year that we are looking for, in this case 2020, and out subtract out the year that we started with, 1995. Okay? So if we do 2020 minus 1995, we're left with, it's been 25 years. That's my t value, and that is what we're going to plug into our equation. So let's rewrite our equation real fast. Equation here would be the 25,000, open parentheses, I forgot a zero, 25,000, open parentheses, 1 plus our value here, 1 plus 0.032, close that parentheses, and we're going to raise it to the 25th power. So we raise that to the 25th power. Let's come over to our calculator. Let's start typing. 25,000, open parentheses, 1 plus 0.032, close the parentheses. You can see, actually, I forgot the plus sign. That actually worked out because 1 plus 0.32 is 1.032. but I'll go back and put it in anyway. So plus 0.032, close the parentheses, all raised to the 25th power for 25 years. There we go. Our answer is 54,945. We're going to round down again because you can't have a decimal. You can't have a part of a person. So 54,945 people. Our population of Johnson City is 54,945 people. Okay, so press pause at this point. Go ahead and give this next problem a shot, and then press play and see if you got it right. So hopefully you're back. Your function should be 96,000, open parentheses, 1 plus, because we're appreciating. Our home that we bought is appreciating. It's appreciating at a rate of 4%, which is 0.04. Close the parentheses. What are we going to raise it to? Well, we bought the home in 1993, and it's now 2009 in this problem. So if we do 2009 minus the 1993, so minus 1993, think about that right there. That'd be 7 years to 2000. 7 plus the 9 gives me 16 years. So we've now owned the home for 16 years. So this is what we raise our property to, our equation to, and you can just plug that straight in your calculator. So if we plug that straight in, 96,000, open parentheses, 1 plus 0.04, all raised to the 16th power. So our total value of the home now is, I missed a 0. So go back and try that again, Crouch. Okay, go back, make sure I got my 0 in there. So put my 0 in, enter. This time, the value of my home is now 179,000, $806.20. So notice how I can use the decimal this time because this is money and we're allowed to use decimals. All right. So those are your practice problems for exponential growth. You're now going to move on and look at exponential decay.